Hi, welcome to today's talk on the conservation of energy. What are we learning? We're going to learn how to make calculations using the concept of conservation of mechanical energy. Our essential question, what can we predict about the motion of an object using the concept of conservation of energy? Energy is something that cannot be created or destroyed. It can only be transferred from one thing to another. Some people have used the analogy of like a bank account. You need to know where your money's coming from and where it's going to. Unfortunately, it doesn't magically appear and fortunately, it doesn't magically disappear. So we need to be keeping up with where it comes from and where it goes to. So let's start by looking at this situation. Let's say we're going to rescue somebody from a burning building. Not to worry, we have our brave firefighters down here ready to catch her with a trampoline. So when she starts her fall, she has potential energy only because she has mass and she is a certain height above the ground. So for simplicity's sake, let's say she has a mass of 100 kilograms. Let's use G as 10 meters per second squared. And let's say that she's 10 meters above the ground. That means that she has a potential energy of 10,000 joules. Her velocity at this point is 0, so she has no kinetic energy. What's going to happen as she falls? She's going to gain kinetic energy because of her increasing velocity. She's going to lose potential energy because the height above the ground is getting less and less. But she will always have, due to the conservation of energy, energy not being created or destroyed, she'll still have 10,000 joules. The total mechanical energy is going to be our kinetic energy plus our potential energy. And when we add these two up, we're always going to get 10,000. So a little ways down, she now has a potential energy of less than 10,000, 7,500, and she's gained kinetic energy, 2,500 joules. Add those two up, and we still get 10,000. Halfway down, her potential energy is 5,000 joules, and now she has 5,000 joules of kinetic energy because her velocity is increasing and increasing. It's accelerating at about 10 meters per second. Getting closer to the ground, this H has gotten to be less, so now she has 2,500 joules of potential energy, and she now has 7,500 joules of kinetic energy. Adding those two up, we still get 10,000 joules. And here's where something interesting happens. Right before she hits the trampoline is going to be our H equals 0. She will have 0 potential energy and all kinetic energy, 10,000 joules of kinetic energy. So if we take her mass, multiply it by 1/2, multiply it by the velocity squared, we should get 10,000 joules, the total mechanical energy of what we're going to call the system that includes her and the Earth has a total energy of 10,000 joules. So to put this in a mathematical sentence, if you will, to start out with, if we took our kinetic energy plus our potential energy, and we had 10,000. Anywhere else along this trip, if we take the kinetic energy and add it to the potential energy, as long as this is an isolated system and we're neglecting, say, an outside force, an outside non-conservative force, such as air resistance, or we'll think of it as friction, then we should get the same number. And in this case, 10,000 joules. From here, we can actually very easily calculate how fast she's going right when she hits the trampoline. Now, before we had to do some fairly complicated kinematic equations, and I'm going to show you right now that this makes it a lot more simple. So here's our situation now, written out on our problem. So we have a final kinetic energy of 10,000 joules. We want to know what the velocity is. Here's our sketch. Our initial potential energy was 10,000 joules. Our kinetic energy was 0. Notice that the total mechanical energy at the bottom here, right before she hits the trampoline, is the kinetic energy is 10,000 joules, but the total, both up top here and the bottom, is both 10,000 joules. Here's what we know. The final kinetic energy is 10,000 joules. We want to know what the velocity is. We have an equation that relates kinetic energy to velocity. Kinetic energy equals 1/2 mass times velocity squared. We are looking for v here. All we have to do is solve for v. Let's do that real quick now. All right, there we go. Now we know what v is. All we have to do is do a little plug and chug. So there we go. She was going 14 meters per second right before she hits the trampoline. All right, let's summarize what we know now. The total energy of an isolated system is conserved. And as long as there's not an external force acting on this system, this should be true. An external force, say, like friction or air resistance. All right, thank you for listening. Don't forget your Cornell notes. Rewind and review as necessary.